The proposal to refer to a concrete encased electrode as a CEE is being considered due to the lengthiness of the full term. The abbreviation's advantages and disadvantages need to be weighed. Firstly, brevity is a major advantage. CEE is significantly shorter than concrete encased electrode, which benefits quick and efficient communication. Secondly, clarity is another benefit. CEE clearly indicates the type of electrode being referred to, avoiding potential confusion with other types of electrodes. Thirdly, the term CEE is already used informally in some electrical industry circles. Standardizing its use would enhance clarity and consistency across the industry. However, there are also potential drawbacks. Firstly, the term CEE may not be familiar to individuals outside of the electrical industry, potentially limiting understanding. Secondly, CEE could be confused with other acronyms in the electrical industry, such as CE code or Common European Electrical Code, which is a set of European standards relating to electrical equipment. When evaluating the use of any abbreviation, it's important to consider the audience. Within the electrical industry, the advantages of using CE may outweigh the disadvantages, especially if the term is clearly defined initially. To mitigate potential confusion when introducing the abbreviation CE, it's recommended to explicitly state that it refers to concrete encased electrode. This can be done in written materials, presentations, or training sessions. For example, one might say, "We will be using the abbreviation CE, which stands for concrete encased electrode, throughout this document." This approach can significantly reduce ambiguity and ensure that everyone understands the intended meaning. Furthermore, consistently using CE within a specific context, such as project documentation or internal communications, will reinforce its meaning and familiarity among team members. Consider including CE in a glossary of terms used within the company or organization. This will serve as a quick reference for employees who may be unsure of the meaning of the abbreviation. When communicating with individuals outside of the electrical industry, it's generally best to avoid using CE and instead use the full term concrete encased electrode. This will prevent confusion and ensure that the message is clear to everyone. If it's necessary to use CE when communicating with a broader audience, provide a clear explanation of what it means the first time it is used. For instance, the concrete encased electrode, or CE, is a type of grounding electrode. The concrete encased electrode, often used in new construction, consists of at least 20 feet or 6.1 meters of bare copper conductor that is at least 4 American wire gauge in size. It is encased in at least 2 inches or 50 millimeters of concrete within a footing or foundation. This type of electrode is recognized by the National Electrical Code, specifically in Section 250.52. A3. Concrete encased electrodes are effective because concrete maintains good contact with the earth and provides a stable, low-resistance grounding path. This helps to protect electrical systems and equipment from faults and overvoltages. When properly installed, a concrete encased electrode offers a reliable and long-lasting grounding solution. The decision of whether to adopt CE depends on the specific needs and context. If brevity and efficiency are priorities within a knowledgeable audience, CE can be a useful abbreviation. However, it's crucial to balance these benefits with the potential for confusion and to take steps to mitigate this risk through clear communication and definition. Consider the communication environment. In internal communications within a company or organization that deals with electrical systems, the use of CE may be widely accepted and understood. In this case, the benefits of brevity and efficiency may outweigh the risks of confusion. However, in external communications, such as when dealing with clients or the general public, it's generally best to avoid using CE and to use the full term concrete encased electrode. This is because people outside of the electrical industry are unlikely to be familiar with the abbreviation, and its use could lead to confusion. When introducing the abbreviation CE, consider providing a visual aid, such as a diagram or photograph, to illustrate what a concrete encased electrode is. This can help to reinforce the meaning of the abbreviation and make it easier for people to understand. If there's a concern that CEE may be confused with other acronyms in the electrical industry, it may be helpful to provide a list of common acronyms and their definitions. This can help to prevent misunderstandings and ensure that everyone is on the same page. Evaluate the frequency of use. If concrete encased electrode is a term that is used frequently in a particular context, the benefits of using the abbreviation CEE may be greater. However, if the term is only used occasionally, the benefits of using the abbreviation may be less significant. Remember to solicit feedback. Before making a decision about whether to adopt CEE, solicit feedback from people who will be using the term. This can help to identify potential problems and ensure that the abbreviation is well understood. Ultimately, the decision of whether to adopt CEE should be based on a careful consideration of the advantages and disadvantages and on the specific needs and context. By following these guidelines, you can minimize the risk of confusion and ensure that the abbreviation is used effectively. For example, consider a scenario where a construction company is working on a large project that involves the installation of numerous concrete encased electrodes. In this case, the use of the abbreviation CEE could save a significant amount of time and effort in project documentation and communications. However, it's important to ensure that all members of the project team are familiar with the abbreviation and understand its meaning. This could be accomplished through training sessions, written materials, or simply by providing a clearer definition of the abbreviation at the beginning of the project. Consider a scenario where an electrical engineer is writing a report for a client who is not familiar with the electrical industry. In this case, the engineer should avoid using CEE and instead use the full term concrete encased electrode. This will ensure that the client understands the report and is not confused by technical jargon. The use of abbreviations can be a helpful way to improve communication, but it's important to use them carefully and to be aware of the potential for confusion. By following these guidelines, you can ensure that abbreviations are used effectively and that communication is clear and concise. When in doubt, always err on the side of clarity and use the full term rather than an abbreviation. This is especially important when communicating with people who are not familiar with the subject matter. Consider also the potential for misinterpretation. Some abbreviations can have multiple meanings, which can lead to confusion and miscommunication. To avoid this, it's important to be clear about the intended meaning of the abbreviation and to provide context when necessary. For example, the abbreviation NEC could refer to the National Electrical Code, but it could also refer to the National Energy Council. To avoid confusion, it's important to specify which NEC is being referred to. Be mindful of the audience's knowledge level. When communicating with people who are not familiar with a particular subject, it's important to avoid using jargon and technical terms, including abbreviations. This will help to ensure that everyone understands the message. In addition to the potential for confusion, the use of abbreviations can also create a barrier to communication. Some people may feel intimidated by abbreviations and may be reluctant to ask for clarification. This can lead to misunderstandings and can make it difficult to build rapport. If there is a chance someone may not know what the abbreviation CEE means, it might be valuable to say the full term out loud and follow it with the abbreviation. For example, you could say, the concrete encased electrode, also known as CEE. Consider the potential for long-term implications. Once an abbreviation has been established, it can be difficult to change it. Therefore, it's important to carefully consider the long-term implications of using an abbreviation before adopting it. If there is a chance that the abbreviation could become outdated or confusing in the future, it may be best to avoid using it. If the abbreviation CEE were to be used widely, one consideration would be whether there would be other uses for the acronym that would cause conflicts. This could require governance of the term. Concrete encased electrodes play a crucial role in electrical safety by providing a path for fault current to return to the source, thereby tripping circuit breakers or fuses and preventing electrical shock hazards. In addition, concrete encased electrodes help to stabilize voltage levels and reduce electrical noise, which can improve the performance of sensitive electronic equipment. Concrete encased electrodes are typically installed during the construction of a building, before the concrete foundation is poured. The electrode is placed in the bottom of the footing or foundation, and the concrete is poured around it. The electrode must be in direct contact with the earth to be effective. The size and type of conductor used for the concrete encased electrode must comply with the requirements of the National Electrical Code. In general, a minimum of 20 feet of bare copper conductor is required. The conductor must be at least 4 American wire gauge in size. The concrete encased electrode must be connected to the building's grounding system. This is typically done by connecting the electrode to the grounding electrode conductor, which runs to the main electrical panel. Regular inspection and testing of concrete encased electrodes is important to ensure that they are functioning properly. The resistance of the electrode should be measured periodically to verify that it is within acceptable limits. If the resistance is too high, it may indicate that the electrode is corroded or damaged and needs to be replaced. The cost of installing a concrete encased electrode is relatively low compared to other types of grounding electrodes. However, the cost can vary depending on the size and type of conductor used, and on the complexity of the installation. In some cases, it may be necessary to hire a qualified electrician to install the electrode. It is important to note that concrete encased electrodes are not always required by the National Electrical Code. In some cases, other types of grounding electrodes may be permitted or required. For example, a ground rod may be used in lieu of a concrete encased electrode if certain conditions are met. Concrete encased electrodes can also provide lightning protection by providing a path for lightning current to flow to ground. This can help to protect the building and its occupants from damage caused by lightning strikes. If the building is located in an area that is prone to lightning strikes, it may be necessary to install additional lightning protection measures, such as lightning rods. Concrete encased electrodes are considered a reliable and effective grounding solution because they are protected from corrosion and damage by the surrounding concrete. The concrete also helps to maintain good contact between the electrode and the earth, which is essential for effective grounding. If the concrete is cracked or damaged, it may be necessary to repair or replace the concrete encased electrode. This can be a difficult and expensive process, so it is important to protect the electrode from damage during construction and throughout the life of the building. In some cases, it may be possible to install a supplemental grounding electrode in addition to the concrete encased electrode. This can provide additional protection against electrical faults and overvoltages. Supplemental grounding electrodes are typically installed near the main electrical panel. There are several types of supplemental grounding electrodes that can be used, such as ground rods, ground plates, and underground metallic water pipes. The type of supplemental grounding electrode that is used will depend on the specific conditions at the site. When selecting a grounding electrode, it is important to consider the soil conditions at the site. The soil resistivity can affect the performance of the grounding electrode. In general, soils with low resistivity are better for grounding than soils with high resistivity. If the soil resistivity is too high, it may be necessary to install a ground-enhancing material to improve the performance of the grounding electrode. Ground-enhancing materials are typically made of bentonite clay or other conductive materials. They are placed around the grounding electrode to improve its contact with the earth and to lower its resistance. The National Electrical Code provides detailed requirements for the installation of grounding electrodes. It is important to follow these requirements carefully to ensure that the grounding system is safe and effective. Improperly installed grounding systems can pose a serious electrical hazard. The resistance of a grounding electrode should be measured using a ground resistance meter. This meter sends a current through the earth and measures the voltage drop. The resistance is then calculated using Ohm's law. The resistance of the grounding electrode should be low enough to allow a fault current to flow to ground quickly and safely. The National Electrical Code specifies the maximum allowable resistance for grounding electrodes. In general, the resistance should not exceed 25 ohms. If the resistance is higher than 25 ohms, it may be necessary to install additional grounding electrodes or to improve the soil conditions. The use of CEE for concrete encased electrode can be efficient if there is an agreement and understanding on what it means for the industry professionals involved.